this being a data flip-flop, you may need to reset it or clear it. So if it is having say 0 or 1, you want to clear it before you set in something. Or if you want to just reset some values, okay, so that you may all want to make the, because these are memory elements, so it's a flip-flop storing either a 0 or 1. You want to set it maybe to 0 all the time, or set it maybe to 1 all the time, whatever it's a preset. Another time is when you are already using it and you want to clear it before you put it so that the other value will not interfere, the already existing value will not interfere. In that case, you need to clear it. So with that, the circuit looks like this. Clock edge coming in, D, that is the data, inverted to the second gate. Then you add a couple of AND gates here. And there is a signal coming in. Please set the signal. This is the construction. The addition of the two AND gates. This signal will be ANDed here. This signal will be there. This signal is 1 as a preset. This one is 0. And this signal is 1 as a clear. So, and the rest is the same. Let us look at the table then with a preset and a clear. So, if the preset and clear are both zeros, it is undefined. But if a preset is 0 and clear is 1, the output is 1. The preset is 1 and clear is 0. Whatever the clock and the data is, the output is 0. Then once again, if you keep, now once you want to, when you want to work with the D flip flop now, if you really have to work with the inputs only, you have to keep preset and clear to 1, because there is an ANDing. So the signal to come out according to this, you need to put a 1 signal here, so that will be ANDed. So both of these are kept at 1. So as usual, when preset and clear are both on, with the levels of the clock and the falling edge, whatever the data is, there will be no operation here. There will be no result that you will receive. Only with the rising edge, if the data is 0 and the preset and clear are set to 1, then with the rising edge and data of 0, output is 0. Rising edge and data of 1, output is 1. And this is basically your clear and preset D flip flop for storing data, as well as for the enabling of setting or resetting this flip flop, so that we can put in some values. Give an example of setting and presetting. When you've all worked with C programming language. Now you see, when you are using a variable and you just don't mean values, but try to print it, garbage value comes out. Why? Because this is the variable is stored in a piece of memory where all these flip flops are there. So together the flip flops and such other devices, memory elements will make up a register. It is in the register or the memory register, or whatever it is, the memory unit. Now, If the just a variable is created, so some memory position is allocated. It is in transistors are in the random state, in a very random state. So if you want to just print the value of that, it will give you this value because it's in a random state. On the other hand, what you should do is when you are when you want to use a variable, you should also always preset it either to a 0 or a 1, as the case may be. For example, if it is a multiplication sequence where you're going to use it, you should always preset it to 1. Because in case you forget to fill in the values, at least the result will remain the same. If you are using it in case of an addition or a subtraction, you preset it to 0. Int x equals to 0. Why? Because in this case, if you forget to populate the value of x into the memory address of x, then at least if you use it directly without populating it with a proper value, the result will remain the same, because something plus 0 is something that remains the same, something minus 0 is also remains the same. So that is exactly what you do. So similarly here also, so this preset and clear, then if you want to flush some memory unit and put its values, it will clear. So that is exactly how this D flip flop comes in handy.